Here we have a nice parametric problem. We have all my working answers here. And what I also did, I graphed the two equations they gave us in my graphing calculator because that's going to make the problem go a lot nicer and quicker for us. But notice on the parametric, they gave us the x prime and the y prime. So we know how fast the x's and y's are moving. And at some point we use this, and we always kind of use that initial point they give us there. So I just kind of underlined a few important things for myself. And then the first couple parts, it says find the speed of the particle and then the total distance traveled of the particle. So remember, in our blue packets, the speed of a parametric is just the square root of x prime squared plus y prime squared. And then the distance traveled, or the arc length of that, like what is traveling there, is just the integral of that same formula right there. So I initially jotted this down. Didn't really need to do. I said that at t equals 2. I could have just put this stuff that I got in the bright blue right there, because it says find the speed at t equals 2. So that's the square root of x prime of 2 squared plus y prime of 2 squared. And x prime of 2 means you just got to take that 2, plug it into your x prime equation for the t's. That's where I got that 12. And then we're supposed to square it. And then y prime of 2, take that 2, plug it in for that t right, for those t's right there. Now I got this 2.722 number that just kind of kept on going in the calculator. So I just left that long number in the calculator when I squared it. And I was able to get that. So make sure you're doing your square root x prime squared plus y prime squared. Plug in the numbers when they give you the numbers right there. And we'll round everything to 3 decimal places there. All right. So they didn't really ask for units on this one, but just if they did, that we know was going to be centimeters per second. So that's the speed of it. And then the total distance traveled is just going to be the integral of that speed formula right there. So it says find the total distance traveled between 0 and 2. So I'm going to integrate that speed formula between 0 and 2. Now, since I already typed these into the calculator, and again, if you didn't type them into the calculator, you kind of start needing it for the next few parts there. You might just want to type them in so it makes the next few steps go a little bit smoother. So what I did, just that's my y1, that's my y2. So when I pop out of there, so I'm going to do the math 9 of this integral. So it goes really quickly. We're going to go math 9 between 0 and 2. And then I need to do my square root symbol. And then we're going to go x prime squared. So I'm going to hit alpha trace. That is my y1. And then I'm going to square it. And I'm going to go plus. And I'm going to go my y prime squared. My y prime, that's my y2. So I'm going to do alpha trace. That's my y2. And I'm going to square that guy. And then it does that integral for us. So you have to make sure you show the setup. That's to your benefit, so you can get that point in case you do happen to bump something in the calculator wrong there. But then that takes us straight to that guy right there. So notice that both of the directions it said show the setup for your calculations there. So you got to show that, and then you can do your calculations in the calculator. You got to show that, then you can do the calculations in the calculator there. But I love that. That just makes it so much quicker for us. All right, so for letter C, it says find the y coordinate of the position at t equals 0. Show the setup for your calculations. Now, this is where a lot of times they give us at time t equals 0 where we're at, and you got to find the y coordinate at like t equals 2. But here's a little bit reverse of that, but I'm still going to use the same setup. So we know where we're at t equals 2, and we want to find what it was at t equals 0. So if I want to find the y coordinate at 2, we would typically start at t equals 0 and then pick it up where we left off, integrate that between 0 and 2. So when you integrate the y prime, that's going to get you your y, and that's all we're focusing on. It doesn't mention the x coordinate to be worrying about the x's. It just mentions the y coordinate. So we're going to integrate the y prime to get the y's, but you always got to take into account the initial thing there. So if I want the position at t equals 2, I start with t equals 0, integrate it from 0 to 2. And then we were given that was equal to 6. That's what the y coordinate at t equals 2 was equal to 6. And this is what we're trying to figure out. So I know in some past problems, it would have those switch. It would give us that one, and we're trying to figure out that one. But I still set up the same exact way. That's the way it works in my brain there. But we were given that one, want to find that one. So I just carried it down. And then this is the integral. We're going to math 9 that y prime function. And again, the y prime, if you forget, if you hit your y equals, that is our y2 in here. So if I go in now, if I use my math 9 function, I want to go type this one in. So we're going to go between 0 and 2 of that. I'm going to do alpha trace, and I'm going to highlight my y2 function. That's going to be my y prime equation, just type that in. And then that gives me this 7.17 number. Remember, we're supposed to go 6 minus that. So I don't know why. I usually type this, and I usually go 6 minus that guy right there. Like I usually type that in first there. So I don't know why I didn't do that there, but it's okay. But just make sure you remember to go 6 minus that. And that's going to get you that negative 1.174. So that's going to be your y coordinate at t equals 0. And then eventually it'll go to like that 6 number at t equals 2. So that's all we needed to do for part C. So just remember, you typically students remember to integrate that y prime, but you got to just make sure you're taking into account like this guy right here and setting that up there. So we've had a few like that. We could group them together and study them. All right, now letter D. It says between just 2 and 8, the particle remains in the first quadrant. Okay, so I'm just taking a mental note of that first quadrant. X and Y's are both positive. Find all times where the particle is moving toward the x-axis. Okay, so there's my interval. We're in quadrant 1. So I just know that means the X and Y's are both positive. So think about it. If you're in quadrant 1 and your Y is positive, so if you're going to move towards the X-axis, it's like you're either going up or down. You're really just worrying about the Y prime. You're worrying about the dy dt. If they're talking about moving towards the y-axis and you're talking moving left or right, that's when you're talking about your dx dt or your x prime. So if I have a point, I'm in the first quadrant, means my y is already positive, so I'm up here someplace. I'm going to be moving towards that x-axis if the y's are getting smaller, if the y prime is negative, and the y prime and dy dt, that's the same thing. So if my dy dt is negative, that's going to be where the particle is moving towards the x-axis there. So we'll get credit if we just get something like that, if we're considering the sign of that dy dt right there. And then now I have to actually figure out where the dy dt is smaller than 0, is negative right there. So my dy dt is the y prime equation. I already have this graph, and what I did is I hit the window button and I made my X min 2 and my X max 8 to give us in between 2 and 8. And then when I graphed it, this popped up. Now I had 2 graphs in there. I guess you could have deleted one, but I just left a 2 in there. And remember, it kind of shows you, if you hit the trace button, it shows you which equation you're at. So if I hit the up or down arrows, I want this one. This is my y prime. I'm trying to figure out where this guy is equal to 0. And I'm looking where it's negative, where it's below the x-axis there. So notice when I trace it, it just kind of puts it somewhere in there, and then we're going to calculate that 0. So if you hit second trace, that's the calculate menu. Number 2 is 0. And remember, we're just going to move it to, so I moved it to the other curve for a second. So I'm going to hit down. I'm just going to move it in the area I want, move it to the left a little bit, make sure those Y's are positive. And I'm going to hit enter, and I'm going to move to the left a little bit, make sure those Y's change sign. And once they go negative, you can hit enter again. And for the gas, I just usually hit enter a third time. And that's how I calculated that 0 right there. So that's how I'm getting this 5.22. So this is technically like what the graph is looking like here. And again, we're moving towards the x-axis. So I want to know where the y prime, where that graph is below the x-axis. So I calculated that point. It's going to be below the x-axis from that 5.22 to the end, which was the 8th interval right there. So again, they gave us that interval, and we're looking for where that graph is below the x-axis, where it has negative y values. So that's on that interval from 5.22 and then end it at that 8 right there. So you just got to mention that is negative, and then you're able to find that from the calculator right there. And if you guys have any questions, just kind of let me know, and make sure you're practicing all those calculator skills by yourself so you're getting comfortable with it and you're getting quick with it as well. Savings account. Save that money. Save that money.